Hello, good morning. How are you? I'm very fine. I'm called Asnaka Hailo. I'm from Ethiopia. I'm working my job in Awasa University as physics lecturer. I'm requested to solve this problem with you. Please, my dears, can we do together? Good. Now it says a string has a mass of 200 grams attached and then it is hanging vertically. What horizontal force produces an inclination in the string of certain degree to the vertical, it says. First, what we have to do, we have to sketch what you call it, the graph. Look, my dears, HTTP, this is the original length of the string. And then if you exert or the horizontal force, if the horizontal force exerted upon the string and then with the mass, we will see some inclination like this. Let it be, my dears, this is a ball or a certain small object which is attached with the string. Great. And then its angle of inclination is, as what the thing is stated here is, 30 degree. Great. So, since it is a string, now we have, or the string has what you call it, a tension force. Since a tension, or simply tension force is a vector, we have to decompose into its component. So the tension force, this tension force should be decomposed to its component. Sx and then is y component. Now let it be this is Tx and then this is Ty. Tx becomes simply T times sine of 30 degree. Ty becomes T times cosine of 30 degree. Great. Now another very important thing is, this is a mass, and then its weight is downward. That is mg, is downward. To be this mass at this position, something is required, that is a horizontal force. That horizontal force should be equivalent with T of x, but it should be opposite in direction. Unless this object never stayed here. To be stay at this point, the component of x component of the tension force and then the horizontal force should be equal in magnitude but opposite in direction. And then to be stay here, the mg is known as the weight of this object, and then the y component of the t of y should be equal, but in opposite direction. If so, this object is staying for a certain period of time with the angle of inclination is here. Now good, what we have to do? T of x or the net force along the x-axis should be 0. This object will be stay there. This implies that T of x minus the applied force should be 0. And then T of x becomes F applied should be equivalent with F applied. Let it be this is equation 1. And then we know that since this object to be here, the sum of all the forces along y-axis should be 0. From this we understand that T of y minus mg should be 0. That means from this and then this we understand that there are no net forces along each directions. So, but we say that Ty is equivalent with T cosine of 30 degree, and then we should be equivalent with mg. From this is equal to mg over cosine of 30 degree. Let's keep this is equation 2. Now what we have to do? We have to substitute. We have to substitute equation 2 into equation 1, and then it becomes, look here my dears, Tx is as what we said, Tx is simply equivalent with T times sine of 30 degree, which is equal to force applied. Now in our this force is required. So force applied is equal to, we have to substitute equation as what we say. We have to substitute equation 2 into equation 1. Then force applied becomes mg over cosine of 30 degree in terms of t times sine 30 degree. So F applied becomes, the mass is 0.2 kilogram, because 200 gram just convert to 2 kilogram, and then it becomes 0.2 kilogram times 10 meter per square of second over cosine of 30 degree is root 3 over 2. And then sine 30 degrees half. And then this becomes simply, this is 2 over 10 kilogram, log 10 meter per square of second, log 1 over 2, the whole over root 3 over 2. Now 2 by 2, by 10 by 10, and then becomes 1 Newton over simply root 3 over 2, and then this becomes 2 over root 3 Newton. So such a force should require to incline this ball with this angle. Thank you my dears for your watching. Please don't forget, like it, subscribe it, and then put your comment up on the box. Thank you. Bye bye.